So we're reviewing for an exam, and the following material is what we covered in our chapter 1, and you had a test over this if you were in my class. The first question that I have on that end of the chapter test was solve the inequality. Express your answer using set notation or interval notation. Graph the solution set. So I have an inequality. I would solve this just like it was an equal sign. The only thing I have to worry about is if I divide or multiply by a negative number, that would switch my sign. I have a fraction in here. I don't tend to like to work with fractions, and because it's an inequality, we could change that and get rid of that 6 in the denominator there by multiplying both sides by 6. So if I multiply 6 times 1, 6, our denominator cancels, and I'm really just left with 1 times x minus 15. So I have x minus 15 is less than, and I need to distribute this 6 to each term on the right-hand side. So 6 times x is 6x, and 6 times 20 is plus 120. So I want to get all my variables, terms with variables to one side of my equation and terms without variables to the other side of the equation. So if I subtract 6x on both sides and I add 15 to both sides, I see that I get negative 5x is less than 135. I know, though, when I divide by negative 5 to get x by itself, that flips my inequality sign. So instead of less than, it's now a greater than sign. So I have here that x is strictly greater than, well, negative 5 goes into 135. Positive divided by negative is negative. And 5 goes into 13 twice with a remainder of 3. 5 goes into 35 7 times. And so I get that x has to be greater than negative 27. Putting this in interval notation, the smallest value I have, but not including, is negative 27. So I put a parentheses and not a bracket. And I'm going off to infinity. Drawing this on the number line, I would determine where negative 27 was. I am not including, so parentheses, and it's everything greater, so I'm shading that to the right. So the next equation, this was an equation, not an inequality. Next problem is an equation, a rational equation. So you always want to start these by factoring the denominator if possible. And so I notice that all of these denominators are factorable. I notice that the first fraction is a difference of squares in the denominator. So x squared minus 25 factors as x minus 5 times x plus 5. Minus x plus 1 all over. I notice x squared minus 5x has an x in common, so I can factor out an x. And so thinking to myself, x times what is x squared is x, minus x times what is 5x is 5, is equal to negative 5. Again, I want to factor this denominator. They both have an x in common, so we can factor out an x from x squared plus 5x, which is x plus 5. So once our denominators are all factored, and this is an equation, we could look at what the least common denominator is of all of those fractions. And I notice that 2 of them have x minus 5 in there. I need an x minus 5 as part of my LCD. 2 of them have an x plus 5 in there. So I need an x plus 5 as part of my least common denominator. And then 2 of them have an x in it. So I also need an x. I'm going to stick it out here. So determining our least common denominator of all the fractions within the equation, we could multiply both sides by our least common denominator so that we can clear the fractions. And so I'm going to multiply each side by x times x minus 5 times x plus 5. And since I ran out of room, I'm just going to actually multiply the whole equation by that. Okay, so we want to distribute to each grouping. I notice when I distribute this to the first grouping over here, first fraction, my x minus 5 and my x plus 5 would cancel over here. And so I would just be left with this x all times what's remaining that didn't cancel, which is x. Minus, so now we want to distribute this to the second grouping on the left-hand side of my equation. And I notice in this case that my x would cancel and my x minus 5 would cancel. So I'm really left with my numerator here. Make sure you put parentheses around that numerator because there's more than one term, x plus 1 times what's remaining that did not cancel out, which in this case would be the x plus 5. This is equal to, so now distributing that x times x minus 5 times x plus 5 to the other side of our equation. And simplifying by canceling out what's in common in the numerator denominator, my x's would cancel and my x plus 5 would cancel. So I'm left with my numerator, which is negative 5, all times what was not canceled, which was the x minus 5. Okay, so we've just gotten rid of all the fractions. And now we want to solve for this. So I notice that I'm going to have to distribute and probably combine like terms. And then I need to decide if I'm going to need to set this equal to 0 or not. Well, x times x, that's an x squared minus. So distributing here, and make sure you have parentheses because that negative is going to have to distribute to this product. So I have x times x, x squared. I have x times 5, so plus 5x. Now distributing my 1 to each term in the next parentheses, 1 times x, so plus x, and 1 times 5 gives me plus 5. This is equal to, so I'm going to carry the sign with my 5. So distributing a negative 5 to each term in this parentheses, I get negative 5 times x is negative 5x, and negative 5 times negative 5 gives me positive 25. So just so I don't have to rewrite everything again, I noticed that there are only 2 terms inside that parentheses on the left-hand side that will combine a 5x plus an x, which is a 6x. Okay, so let's distribute our negative outside of that parentheses. I'm going to bring down my x squared because I haven't used it, but distributing that negative 1, I have negative 1 times x squared is negative x squared. Negative 1 times 6x gives me minus 6x. Negative 1 times 5 is minus 5 equals negative 5x plus 25. So combining like terms, x squared minus x squared cancels. So I'm left with a negative 6x minus 5 is equal to negative 5x plus 25. So simplifying, I noticed that I no longer have a quadratic equation because my square terms canceled. And so I approach solving this linear equation different than a quadratic. So when all the terms with x to one side of the equal sign, all the terms without the x to the other side. So let's add 5x to both sides to get the x's to the left. And let's add 5 to both sides to get the constants to the right. So negative 6x plus 5x is negative x is equal to 25 plus 5, which is 30. Divide through by a negative sign, we get x is equal to negative 30. You need to be careful when you're solving these rational equations that we don't have an answer that sets our denominator equal to 0. So really technically, at the beginning, I probably should have said, okay, well, x cannot be. So I would think about what values of x set each piece of these factors equal to 0. So x couldn't be 5 because 5 minus 5 is 0. X can't be negative 5 because negative 5 plus 5 is 0. And x can't be 0. So my solution that I got was not one of those numbers. So I'm okay. And I get x is equal to negative 30. So the next example we have is x squared plus 81 equals 0. And the direction says solve the equation in the complex number system. So I noticed that I can't factor x squared plus 81, but I also noticed that I can use my square root method because I have a perfect square in here. And so I could isolate my x squared on both sides, on one side of the equation, and subtract 81 on both sides. So I get x squared is equal to negative 81. And now I want to use my square root method, take the square root of both sides to get rid of the square. Don't forget, if you take the square root of both sides, to put the plus or minus in front of one of the radicals. I tend to do it with a 1 with a number on it. Well, the square root of x squared is just x. This is equal to plus or minus. Well, the square root of negative 1 is I, and the square root of 81 is 9. So this will be plus or minus 9i. So the next example we have, it says solve the following inequality, graph the solution set. So we have an absolute value inequality. To solve for absolute value inequalities, the first thing that you want to do is isolate your absolute value. So I don't want that minus 11 on the left-hand side of my inequality, so I would add it to both sides. So I would have 1 minus 4x, the absolute value of that, is less than, adding 11 to both sides, I have negative 8 plus 11 gives me 3. Depending on the absolute value, the inequality, depends on how I'm going to rewrite it. If you had the absolute value of some expression x is less than some number k, to drop the absolute value, you're going to sandwich it in between the positive and the negative of whatever that number was. Well, that's the case I have here, but let me just write it out really quick. If it had been greater than some constant k, then to drop the absolute value, it's either greater than k or x is less than the negative of k. So using my rule, I have my absolute value isolated for that inequality. To drop it, I'm going to sandwich it in between the negative of whatever my number is, which is 3. So negative 3 has to be less than 1 minus 4x, which is less than 3. So we're trying to get x by itself in between both inequalities. So first thing you want to do is subtract 1 on both sides. And if I subtract 1 on both sides of my inequalities, I have negative 3 minus 1 is negative 4, is less than negative 4x, which is less than 3 minus 1, which is 2. So I want x by itself in between both inequalities, so I can get rid of the negative 4 in front of my x by dividing everything through by negative 4. The problem is I'm dividing by a negative and I'm dealing with inequalities. So that changes the sign of my inequalities. So instead of a less than there, I'm going to have a greater than. Instead of a less than here, I'm going to have a greater than. So I'm going back. Negative 4 divided by negative 4 is 1. So 1 is greater than x, which is greater than 2 divided by -4 and reduced to -1/2. I don't tend to like my inequalities facing in that direction, so I'm just going to rewrite it where I have the smallest number first. So -1/2. Notice the less sign is pointing towards the -1/2. So -1/2 is less than x, which is less than 1. So that is my inequality notation. If I put it in an interval notation, it doesn't have the equal to on my inequality, so I'd have -1/2, a parentheses around that, comma, 1 parentheses. Graphing it, I'm looking at parentheses around -1/2, a parentheses around 1 because it doesn't have the equal sign, and shading everything in between. So the next problem we have is the speed of a moving walkway is about 2.8 feet per second. Walking on the moving walkway, it takes Maria a total of 50 seconds to travel 70 feet with the movement of the walkway, and then back again against the movement of the walkway. What is Maria's normal walking speed? Okay, so we have two things. We have Maria walking with, I'm going to create a table, the walkway, and against the walkway. I know that this is a distance problem. Distance is equal to rate times time. Distance is equal to speed times time. So I'm going to go back in and I'm going to read this a little more again. So the speed of the moving walkway is about 2.8 feet per second. So I know if I'm going with a walkway, it's going to increase my speed by 2.8 feet per second. If I'm walking against it, it's slowing me down, and that's going to slow me down 2.8 feet per second. So let me continue to read on. Walking on the moving walkway, it takes Maria a total of 50 seconds to travel 70 feet with the movement of the walkway and then back again against the movement of the walkway. Okay, 70 feet with the movement of the walkway and then back again. So that tells me that the total distance is 70 feet, but it's the same distance each way. So if I look at 70 divided by 2, that is 35 feet is the length of the walkway. Okay, so I know what the distance is. It's 35 going there, and it's 35 feet coming back. I do not know the speed that she's walking. But I know let R equal the speed of walking without going on the runway or walkway. So if I'm going with it, I would have my speed plus the 2.8 feet per second. And if I'm going against, I'd have my speed of walking minus the 2.8 feet. And I know that that total time is 50 seconds. Okay, so I know the total time. So let's look at it. Distance equals rate times time. I know if I look at the time going there, plus the time coming back, that's equal to 50 seconds. So let's rewrite our distance equals rate times time in terms of time. So I can get time by itself by dividing both sides of my equation by r. So I know that time I can express as the distance divided by the rate. So let's look at the time with. The time with the walkway is the distance, which is 35, divided by the speed, r plus 2.8. The time against is equal to the distance, which is 35, all over the speed, in this case is r minus 2.8. So if I add those times together, so 35 all over r plus 2.8, plus the time going against, which is 35 all over r minus 2.8, I know that this total time is 50 seconds. So I've set up the equation. I now need to go through and solve. It's a rational equation. I would look at my fractions. I would look at my least common denominator. I would multiply both sides by my least common denominator of all the fractions within the equation. So I could clear my fractions. And I noticed that my LCD is r plus 2.8, r minus 2.8. So distributing, I would be left with my 35 all times, well, the r plus 2.8 cancels, so I'm left with r minus 2.8 plus, so distributing the LCD to the second fraction, my r minus 2.8 cancels, and I'm left with 35 times r plus 2.8. And this is equal to, and I'm going to have to distribute. So 50. And let's distribute first this. R times R is R squared. R times negative 2.8 is negative 2.8 R. 2.8 times R is plus 2.8 R. And 2.8 times 2.8. So that 2.8 quantity squared gave us 7.84. So plus, or actually minus, because a positive times a negative, 7.84. Okay, so I need to start distributing and combining like terms. So distributing my 35 times R, I notice I get 35R. 35 times negative 2.8. That gives me minus 98. Plus 35 times R is 35R. 35 times 2.8. So plus 98 is equal to, I notice inside this parentheses on the other side, my negative 2.8R plus 2.8R cancels. So let's distribute our 50. 50 times R squared is 50R squared. And 50 times 7.84 would give me negative 392. I noticed that I can combine like terms on both sides. A 35R plus a 35R, that's a 70R. Negative 98 plus 98 cancels, is equal to 50R squared minus 392. Noticing that this is a quadratic equation, I want to set this equal to 0. So I'm going to subtract 70R on both sides. That is not a like term with anything. So I would bring down my 50R squared minus my 70R. minus 392. This is equal to 0. I really don't want to factor that, so I would probably plug that into my quadratic formula. So negative b, so negative of negative 70 is 70, plus or minus the square root of b squared, so negative 70 squared, minus 4 times a in this case is 50, times c, which is negative 392. All divided by 2 times a, and a in our case is 50. So I would have my r is equal to 70 plus or minus the square root. Negative 70 times negative 70 is 4,900. And let's look at 4 times 50 times 392. And I would add it is 78,400 all over 100. So 78,400 plus my 4,900. So R is equal to 70 plus or minus the square root of 83,300 divided by 100. So now I'm going to start rounding. So R is approximately 70 plus or minus the square root of 83,300 gives me approximately 288.62 all over 100. It's not going to make sense to have a negative speed for walking. So I notice that 7 minus 288.62 is going to be negative. So I get my rate of my speed is about 3.586. And we're doing feet per second. Okay, so looking at the next question, we are trying to write the following in standard form of a plus bi. We have a division of two complex numbers, 9 minus I, all divided by 6 plus I. If you're dividing by a complex number, we can get rid of that complex number in our denominator by multiplying through by the conjugate of that number. Well, the conjugate, remember, is just changing the sign in between our two terms. So the conjugate of 6 plus I would be 6 minus I. This is not an equation, so I couldn't just do this to both sides of the equation. So to manipulate it, I'm rewriting this as a fancy one, 6 minus I all over 6 minus I. So now I would go through and distribute 9 times 6, that's 54, minus, well, 9 times negative I is minus 9I. Negative I times 6, this is minus 6I. And negative I times negative I, that's plus I squared. But recall, I squared is negative 1. So we'll go back in a second and change that. All over, well, this is a difference of squares. So I can just square my first term minus the square of my second term. Or I can just distribute. 6 times 6 is 36. 6 times negative I is negative 6I, but then adding 6I cancels. And I times negative I, that's negative I squared. So let's go back in, rewrite I squared as negative 1. Let me look at combining like terms. Just do it above. So I have 54, really minus 1, which gives me 53. Negative 9I minus 6I, is negative 15i, so minus 15i, all over 36 minus a negative 1, which is really 36 plus 1, which is 37. If you type this into MyLab, it would mark you wrong. This is not quite in this form of a plus bi, so we want the real part plus the imaginary part. Because it's one term in the denominator, we can rewrite it as 53 over our denominator, 37, minus 15 over our denominator, 37 times I. So my real part would be the 53 over 37, and my imaginary part would just be the negative 15 over 37. The following question says, find the real solutions of the following equation. If k equals x plus 4 all over x minus 4, and k squared minus 3k is equal to 10, find x. So let's first look at this quadratic, and let's solve for k there. Once we know what k is, we're going to go back in here and plug it in to this rational equation and solve for x. So going over here, I notice that it's quadratic, so I'm going to want to rewrite it so that it's set equal to 0. I'm going to want to subtract 10 on both sides. So doing so, I get k squared minus 3k minus 10 is equal to 0. I notice that this is factorable. There are two numbers that multiply to give me that negative 10 and would add to give me negative 3. So those two numbers are negative 2 and positive 2. So I can factor this as x minus 5, that quantity times the quantity, not x, k minus 5, and that quantity times k plus 2 equals 0. So I notice that k minus 5 is equal to 0 when k is 5, and k plus 2 is 0 when k is negative 2. So now I'm going to go back, and I'm going to have two separate equations. I'm going to have k, which is 5, equal to x plus 4 over x minus 4. And I'll also have another equation, k, which is negative 2. So negative 2 is equal to x plus 4 all over x minus 4. So solving each for x, I want to clear my fraction. I can do that by multiplying both sides by x minus 4. Let's distribute our 5 to x minus 4. So 5 times x is 5x, minus 5 times 4 is 20. X minus 4's cancel, leaving me with x plus 4. Linear equation, get x's to one side, constants to the other, subtract x, 5x minus 1x is 4x. Add 20, so 4 plus 20 is 24. Divide both sides by 4, I get x is equal to 6. So there's one answer. You want to solve that second rational equation. Again, we can do so by clearing our fraction. Multiply both sides by x minus 4. Let's distribute my negative 2 to my x minus 4. So negative 2 times x is negative 2x. Negative 2 times negative 4, so plus 8, is equal to x minus 4's cancel, so it's left with x plus 4. Getting variables to one side, subtracting x on both sides, negative 2x minus x is negative 3x. Let's subtract 8 on both sides. 4 minus 8 gives me negative 4. Now get x by itself, divide through by negative 3. I get x is equal to positive 4/3. So we have two solutions, x equals 6 and x equals 4/3. So the following says, find the real solution of the equation. We have 4 times the quantity of s plus 5 quantity squared, minus 27 times the quantity s plus 5, is equal to 7. So I could expand this all out, get everything to one side and solve. Or I notice that this almost looks like a quadratic. If I choose u to equal to what's inside the parentheses, s plus 5. So I'm going to go back in here and I'm going to rewrite it. Wherever I see s plus 5, I'm going to put a u there. So doing so, I would have 4. I see an s plus 5 there, so u quantity squared minus 27. I see x plus 5, so replace it with u. And let's subtract 7 on both sides so that we can have this set equal to 0. So minus 7 equals 0. So now it's quadratic. I can go ahead and solve. I can use the quadratic formula. I can complete the square. I could try to factor it. I'm going to try to factor it using my AC method. So 4 times negative 7 is negative 28. So I'm looking for two numbers that multiply to negative 28, but add to negative 27, which I know is negative 28 and positive 1 would multiply to negative 28, and negative 28 plus 1 is negative 27. The trick is to rewrite your middle term using those two numbers you found. So I can rewrite negative 27u as negative 28u plus u, then minus 7 is equal to 0. Factor by grouping. So 4u squared minus 28u, I'm pulling out what they have in common. I can factor out a 4u. If I factor out a 4u, I'd be left u minus 7. So I notice that u minus 7 doesn't have anything in common, but it's the exact same thing that I had left when I factored out the 4u. So if it helps you, I usually don't put the 1 there unless I'm doing this factoring by grouping. I can think of it as positive 1 times u minus 7. So now we're factoring out that parentheses because they both have the same thing in the parentheses, u minus 7. If I pull out the parentheses u minus 7, I'm left with 4u for the first piece and plus 1 for the second piece. So we want to solve each of these for 0. So when is u minus 7 equal to 0? It's when u is 7. And I want to know when is 4u plus 1 equal to 7. I'm sorry, not 7, 0. Subtract 1, divide by 4, u is negative 1/4. The thing is, I don't want u, I want s. So go back in and let's plug it into what we had let u be. So I know 7 is equal to s plus 5. So I can get s by itself by subtracting 5 on both sides. If I do that, I get s is equal to negative 2. I'm sorry, not negative 2, positive 2. The other equation I would have is plugging in u into this equation. I would have negative 1/4 is equal to s plus 5. So I want to get s by itself. I would be subtracting 5. I notice I'm going to need a common denominator. So let's multiply 5 by 4 over 4. And let's subtract that on both sides. So I would have negative 1/4 minus, well, 5 times 4 is 20. So minus 20 over 4 is equal to s. Now I have a common denominator. I'm just adding the numerators together, keeping the denominator the same. So negative 1 minus 20 gives me negative 21. And then this is all over 4. It wants it to type as simplified fraction or integer, which this is. So the next equation is the absolute value of 7x minus 2. And that 7x minus 2 is all over 2x minus 5. And your absolute value is equal to 4. Solving absolute value equations, you want to isolate the absolute value if it's not already done so. Once it's isolated, you want to set it equal to the other side and the negative of the other side. So I want to take what's inside the absolute value, not changing anything, 7x minus 2 over 2x minus 5. Set it equal to the other side, 4. And we're going to want to solve that equation. And then we also want to take what's inside the absolute value, 7x minus 2 all over 2x minus 5, and set it equal to the negative of the other side, negative 4. Because I know if what's inside the absolute value in here is negative 4, take the absolute value negative 4, I would get back positive 4. That's why we have two separate equations. Again, hopefully you're getting used to clearing your fractions. We want to clear our fraction. It's an equation. So let's multiply both sides in this case by 2x minus 5. Fraction goes away. I'm just left with my numerator. 7x minus 2 is equal to, let's distribute our 4. So 4 times 2x is 8x. 4 times negative 5 is negative 20. Get terms with x on one side, terms with variables on the other side. Just because I see that I'll get 1x if I subtract 7x on both sides. Let's add 20 to both sides. Negative 2 plus 20 is 18, is equal to 8x minus 7x is just x. So I get x is 18 for the first equation. Doing the same thing, second equation. Clear our fractions. We can do that by multiplying by our denominator, 2x minus 5. That would clear my fraction, leaving me with 7x minus 2 is equal to, let's distribute the negative 4. Negative 4 times 2x is negative 8x. Negative 4 times negative 5 is plus 20. Get variables to one side, adding 8x to both sides. Get constants to the other side, so let's add 2. So I have 7x plus 8x is 15x. This is equal to 20 plus 2, which is 22. Divide through by 15, I would get 22 over 15. That does not reduce. And so we have two solutions, 18 and 22 over 15. So find the real solutions of the equation, the square root of 5 minus 4 times the square root of x. That is equal to the square root of x. So if I'm solving equations with radicals, I would isolate one of the radicals to one side of the equation, already done. I'd raise both sides of my equation by the index. In this case, I would square both sides of my equation to clear the radical that's isolated. Well, that square is going to get rid of this main square root. And so I'd be left with what's underneath that radical, 5 minus 4 square roots of x. And this is equal to square root of x squared is just x. So I want to repeat that process, but in order to repeat that process, I want to get that the square root of x by itself. So I could subtract 5 on both sides. If I did that, I get negative 4 square roots of x is equal to x minus 5. I notice I could divide by negative 4, but then I would be dealing with fractions. So I am just going to square everything right now. If you are squaring a product, you're squaring each factor of that product. So negative 4 times negative 4, that would give me 16. Square root of x squared gives me x is equal to, so x minus 5 quantity squared, let's rewrite that out, x minus 5 times x minus 5, and then let's distribute that. So bringing down my 16x, I have, this would be x squared. This is a negative 5x and a negative 5x. Summing those is negative 10x. Negative 5 times negative 5 is plus 25. I notice this is quadratic, so I want to get x by itself. I'm sorry, I don't. I want to set this equal to 0. let's subtract 16x on both sides. I would get x squared. Negative 10x minus 16x is negative 26x plus 25 equals 0. I notice as factors. There are two numbers that multiply to give me negative or positive 25, which is negative 1 and negative 25. And if I sum negative 1 and negative 25, I get my middle term, negative 26. So this gives me that x is equal to 1 and x is equal to 25. Be careful when we raise both sides of an equation by an even powered. We might get solutions that are called extraneous solutions, meaning they actually don't work. And so I have to check my work. We're going back in and we're plugging it in to the original. Wherever I see an x. So just erase all that square. So I'm gonna check, does the square root of 5 minus 4 square root, I see an x, replace it with 1. Is this really equal to the square root? I see x, so replace it with 1. Well, 5 minus 4 times square root of 1. Well, square root of 1 is 1. So I have 5 minus 4. That's the square root of 1. Yeah, that's equal to the square root of 1. So I know 1 is a solution. Checking x equals 25, though. So I'm going back in here and plugging in 25 wherever I see an x. I would get the square root of 5 minus 4 square root of 25. Is this really equal to the square root of 25? Well, simplifying, this would be 5 minus 4. Well, square root of 25 is 5. So 4 times 5. Does that equal the square root of 25, which is 5? I can already see that that's not. 5 minus 20 is the square root of negative 15. Square root of negative 15 does not equal 5. So that 25 is not part of my solution set. And the only one that works is x equals 1.